welcome. This is Jake Valancourt with 10X Engineered Materials, and I'm joined today by Moose Cooper and Ed Schmidt from 10X. Moose is with Cerakote. We're going to be talking today about Cerakote's evaluation of 10X's EpiX MP in the real world, and I'll hand it off to Moose.
Hey guys, my name's Moose. I'm the training and robotics supervisor here at NIC Industries in the lovely Southern Oregon. We're just going to go over a couple data points and some tests that we ran with 10X with Cerakote over the top, just to make sure that we're delivering the same awesome product that you guys have always loved and enjoyed. Look forward to having a good conversation today. Ed?
Ed Schmidt, Director of Engineering, and we're based out of Wabash, Indiana, and I'm located in Knoxville, Tennessee. So looking forward to it and really appreciate all the work that you've done, Moose. The team at NIC has just been excellent to work with.
All right. So how did we even get to this webinar here? Why was NIC looking for a new blasting media? Well, as many of you guys know, during COVID, it got really difficult to get 100 grit aluminum oxide or garnet sand. We do recommend 100 grit for almost every type of application with our coating. And with the struggle of trying to find it, we stumbled into 10X at FabTech in 2023 or 2024. And we started having a conversation, and I actually just typed 10X Engineered Materials into Google, gave him a call just to see what it was about. And didn't you answer the phone, Jake?
Yeah, so it was kind of funny, Moose. Normally I don't answer the phone, but I do. I'm backup after hours, and 10X prides itself on excelling in not only high performance products, but delivering what we like to think of as high performance customer service. So you'll be able to get a real person who works directly for the factory when you call 10X. And because you guys are West Coast and we're mostly on the East Coast, it rolled into me, and I think we chatted for like an hour and a half. We had a great time. But yeah, you told me right up front, you were like, Jake, happy to talk to you, man. It's been hard. We've had a hard time getting some of this stuff, and we need to look at other options, and it looks like you guys have something unique. So I obviously connected you to the engineering team. I'm not an engineer myself, but I got you hooked up, and over the last year or so, we've been working together to get to this point. So we're really excited to kind of share some of what we all learned as we went through this process.
Yeah. And like I said, we recommend 100 grit, and I really wasn't trying to reinvent the wheel. And when you mentioned that you have the EpiX MP line, and it being that blend, that 70 to 100 grit blend, I was a little hesitant, but I was like, you know what, let's give this a try, because I think this might be able to answer multiple things for us. And then on top of just knowing that you had a good amount of stock and it could potentially work, the safety side of it was eye-catching for me. We have blast cabinets all over this building, and we're blasting all day, every day. So the exposure to that dust and stuff was definitely a good thing to see from an abrasive company. So that's kind of why we started to evaluate a new blasting media. Was our applicators were just having a tough time finding exactly 100 grit. And, sometimes you can buy an 80 grit and you can blast some practice parts for a while and let the media break down to get into 100, but there's no exact science for that. So we were just looking for another alternative. So when we started talking with 10X, there were just a couple things that we were looking for. With us being a thin film ceramic coating that is direct to substrate, our adhesion is absolutely everything. So I just wanted to make sure that because 10X has that range of media, are we able to achieve the same micron depth of blast profile? And with a little bit of tweaks on the blast cabinet and blasting pressures, I think we were able to get it. So adhesion was a big one that I was looking for, making sure that we're getting edge coverage, making sure that we're able to meet or exceed the durability that we were already seeing with aluminum oxide or garnet sand. And then an exciting one here was thermal cycling. most of the time we would recommend on harder metals, especially with high temp coatings, going up to an 80 grit blasting media to get better adhesion under the high temp. Well, with the 10X being that blend, maybe one media could do all of it. It could offer that 100 grit blast profile, but it could also offer that 80 grit blast profile depending on pressure. And then most important overall is making sure that the Cerakote looked the same, right? Everybody loves the look and feel of Cerakote. We just wanted to make sure over a different blast profile that we were able to achieve the same aesthetics. So that's really what we were looking for. And that's kind of what I was testing for throughout this whole process. Through the testing process, I tested a variety of different series of coatings. First three would be H series, Elite series, and F series. These are all three two-part oven cured coatings, and they're really known for the corrosion protection, abrasion resistance, your scratch and gouge resistance, but then also the flexibility of the coating. So I put a lot of testing and spraying out panels and parts and testing all three of those different coatings to make sure that we kept the same adhesion, we didn't lose the flexibility, we didn't lose any corrosion hours, and we were still able to maintain the abrasion and all of the other durability check marks that we get with aluminum oxide and garnet sand. With the bottom three, I did test C series, Glacier series, and V series. I tested these for the high temp capabilities. So we tested these on a variety of headers and suppressors. So titanium, Inconel, stainless steel, the harder metals. And we were able to achieve an aggressive enough blast profile that we were able to maintain adhesion when exposed to high temps. So that was a really, really good thing to see. Through the testing that I did, I tried to hit all the main ASTM testing that we do for all of our coatings. We have this data already published on our website for each individual color of how does each color fare through all of these tests. So I picked, I don't know, 25, 30 different colors, and I sprayed out just to make sure if we were getting a 9H on scratch and gouge, I wanted to make sure that we weren't losing anything on that test when blasting with 10X. Through all of these tests, I saw 0 red flags. I saw 0 decrease in performance. I actually saw on a couple colors, we did get increased performance on a couple of them, but we were able to maintain the same UV stability, the same abrasion resistance, the same corrosion hours, the same hardness. We were able to get the same results on mandrel bend, impact resistance, and then the most important, the cross-cut adhesion. The cross-cut adhesion performed very well on the 10X. I made sure to do these tests on steel and aluminum, and then we ran some of the specialty tests on some of those harder metals, like I mentioned, Inconel, stainless steel, and titanium. Throughout all of the testing that we did, the 10X blast profile matched and kind of exceeded what data we were getting already. The one that was notable was just on a gouge test on burnt bronze. Normally we get 7H on that test, and we were actually able to achieve a 9H when blasted with 10X. I thought that was really cool. And then C102 and C7700 were the main two colors that I used on our thermal testing. We ramped it all the way up to 1800 degrees and then cooled all the way back down to room temperature, and both of them still maintained adhesion, which was really awesome. In the chart on the right on this slide, we have a little snapshot of what a technical data sheet would look like. And these are just the results from the normal ASTM tests that we run. And all the colors that I sprayed with 10X was able to meet or exceed what was already shown on our TDS. So all in all, it was a very, very good showing, really good data. And it's awesome to have another, tool in the tool bag when it comes to a new blasting media and a new abrasive. Ed, would you like to take over and talk about what EpiX MP is?
Yeah, I appreciate it. And that's a great transition. Both companies are focused on technical development and technical excellence. And, just with that, we also provide excellent technical support. I know that Jake mentioned that at the beginning, and just from the work that I've done with you, Moose, knowing that you guys have live technical support for all of your products, it really showed how both companies were very well aligned in what we value for customer experience, which was exciting. Because as we got into this, this was a long process that we were both undertaking together, and we're very happy to see how it turned out with the ultimate approval. So what is the material? It is a specifically designed blend of oxide minerals. It's a superoxalloy. It's manufactured and it's not mined. So this material in the development or in the manufacturing process is a formulation that is made to be durable. And that is done in the mineral wool manufacturing process. And through that recipe that develops a durable particle, a durable material, we benefit from the durability in generating an exceptional abrasive. So this specifically formulated material is also benefiting from years and years of testing that's been done for health and safety. And we'll cover that on the next slide, but it's a US made product that we ship domestically and internationally. So what is it about that durability that gives you the results and the experience that you were talking about, Moose? What does that? Well, that durability means that the material performs very, very well in impact. It doesn't break down. And so that lack of breakdown means that it's low dust and provides good visibility when folks are using it in a cabinet. That durability also ensures that you have a clean surface. That clean surface occurs because the particles aren't breaking down and therefore they're not embedding. And when these particles don't break down because of their durability, they're able to deliver exceptional blasting speeds, whether you're removing difficult powder coating or just prepping a surface in order to apply Cerakote. Then that durability really rounds out the whole suite of benefits by providing for increased reusability. And I know when we were talking previously, you had a question about whether or not folks would see additional cycles over aluminum oxide. And we typically hear that. And it is something that folks experience. I know when we were talking about this development, Moose, you had asked me like, hey, are we going to be similar or better? It's similar or better is normally where folks land, which has been a strong benefit for folks that makes the switch.
I've actually noticed myself here at NIC, the media holding up a little bit longer than the normal aluminum oxide and garnet sand. We're getting a little bit more longevity out of it, which is nice.
Yeah, I appreciate you sharing that, because it's something that when folks have the material dialed in properly, in which we work with anybody to get to that point, when it's dialed in, it's low dust, it's fast, and it is highly reclaimable. And so those are our hallmarks that folks really enjoy. So I mentioned that it's upcycled mineral wool. And, why is that important? Well, one, it's important because we talked about the durability. If you were to make this material, it would be extremely expensive to just make it from scratch. But because it's upcycled, you get the benefits of a ceramic particle essentially at an affordable price. That's the performance side of it. On the health side, now you get the benefit of decades of study that have gone into the health effects on mineral wool. And it's the most, or one of the most studied materials in history. So over the decades, humans and animals were studied as they were exposed to mineral wool dust. And eventually the World Health Organization's International Agency for Research on Cancer convened to study all of that information. And at the end of that review, concluded that the material was in the safest category. And that determination, putting it into the category of coffee, removed this material from lists of possible carcinogens worldwide. And we're not aware of any other abrasive that has the ability to make that claim or that has that level of safety verification, which is, you mentioned it, Moose, when you were talking about, what it was possible, but it really puts it into a different light for folks that are, have that concern or want to know that they're operating with a safe material. So now, as you're thinking about a transition from an existing abrasive that you have over to EpiX MP, you're going to see some differences because it performs differently. And these are good differences. They are what was tested when Moose did the Cerakote applications and did all those tests. But you're going to see a brighter finish. And what you're seeing here on the screen on the left versus the right is a good example of what you'll see. So what I learned when we were working together, Moose, was that the definition up until this point for a thoroughly blasted surface was one that was dull. And that dull surface meant that everything had been covered. With an EpiX blasted finish, it's going to be bright. And that bright finish, even if you were to look at it under a microscope, you're going to be able to see clearly that it is completely covered. Moose, would you mind speaking about just the microscopic analysis that you guys did in the lab?
Yeah, we were able to take a couple panels, a couple blasts with aluminum oxide, and then one blasted with garnet sand, and then we had one blasted with EpiX MP. We were able to look under a real high-powered microscope, and we noticed that the aluminum oxide and garnet sand left a little thin barrier of dust within the profile. And on the EpiX MP one, it had a real bright, shiny look to it. And if you put them side by side, you would almost think that the EpiX MP one wasn't blasted. But after looking under the microscope, we noticed that that dust barrier film wasn't there, and you were just getting an ultra clean blast profile. So it does take a little bit of a training of the eye to know, like, hey, this is properly blasted. It just looks so different from what most people are used to with aluminum oxide or garnet sand.
Yeah, thank you. And that clean surface is what allows the coating. As you said, it's so important to have that clean surface for Cerakote to do what it does. That enables all the performance characteristics that you talked about during the testing. The other thing that's interesting is because it's the blend that you were mentioning about of 70 to 100, there are some settings that need to take place, and we can talk about those. The other thing that's different is aluminum oxide and garnet are a higher density than the EpiX material. So for reclaim, you're going to want to adjust your reclaimer to make sure that the lighter EpiX material is not ending up carried over into your dust collector. So to achieve these, you're going to want to make sure that you're operating at the recommended pressures and that you're metering properly. And Moose, you have a table there that's specific about the pressures. Do you want to speak a little bit about how that came about during the development?
Yeah. So I used a piece of equipment called a profilometer during these tests that I ran, and that pretty much measures your RA value, or how deep of a blast profile you're achieving. And one thing that I noticed, because you do have that blend of media, blasting your softer metals like brass or billet aluminum, blasting those at 100 PSI, you were actually achieving a little bit too aggressive of a profile. So on this chart, and what I put in the write-up on our website was just a different range based off of substrate. So normally we recommend 80 to 100 PSI for all metals, and then 30 to 40 PSI for non-metals. The 30 to 40 PSI still stands true for composites and non-metals. 40 to 60 PSI is what we recommend for your softer metals. So your brass, your aluminum, stuff like that. And then we're able to still blast at that 80 to 100 PSI for your normal metals. So your steel, your galvanized, your titanium, stuff like that. And we're able to achieve the appropriate blast profile.
Yeah. Well, and what was really interesting to me as we were doing the prep for the webinar was to understand that the way that you guys managed that previously for the high temp coatings was that you would have customers shift and stay at the 80 to 100 psi, but you'd have them shift to a more coarse abrasive and then shift back. And so that was the customers having to make media changes. Whereas now with the EpiX MP, you're able to recommend one abrasive for all uses, and they can just adjust their equipment to accomplish the profiles that are necessary and really avoid media changes is what I learned when we were talking about it.
Yep.
So that was a wonderful learning. So Jake, I'm going to pass it back to you at this point so that you can go into folks and how they would get started with the material if they choose to make that switch.
Yeah, thanks, Ed. So, like we said before, both companies are huge on providing expert customer support and a high quality of customer service. We're both US based. And I want to mention that Cerakote has put a knowledge base article on their webpage. So if you're anywhere on the Cerakote website, in the search, just type in 10X and you'll find it. There's one singular page that has the core information. And then if you need more details, like technical details on EpiX MP, it will link to a specific page we built, which is also listed here for Cerakote applicators where you're going to use EpiX MP. 10X did develop even more details and suggestions on how to transition. And of course, the 10X technical support team is available to anyone who is even contemplating transitioning or they already have and they want some help dialing it in. You can send videos to us and we can look at what your blast is looking like, or you can chat with us, call us on the phone, set up a virtual call. And for larger customers where they need on-site support, that's available complimentary. And for smaller customers, if the smaller folks want that type of help, we have service packages that are available for purchase as well. And we got our contact details on this slide, but I do want to mention before we jump in that part of why Moose was looking was there was some supply issues. And in the beginning of this process, what Moose, you shared with me was, look, we had times where you and your customers couldn't get an abrasive that was approved in either category. It didn't matter. It was just became unavailable, right? We had mine closures. There were issues of foreign source materials. 10X is made of mineral wool, and there's an abundant supply of that. Yes, our product is patented. It's definitely unique, but we have a huge supply of the raw material, and we have, over 100 trucks in stock. When I say a truck, one truck is 44,000 pounds. We have a tremendous inventory. Our products generally ship same day or next day, depending on what time you order on our website. I mean, we're ready. There's no problem here with the supply, and we have a fantastic production team. So, we can surge as the market demand does this. It tends to be that we get some months that are really busy and some months not. That's normal, but we're ready for it. And, we're really happy to be supporting all the Cerakote and NIC coders out there. So in the Q&A and I see there's quite a few questions here. Let me just mark this one before we jump into some of these very specific technical questions. I'm going to try to start broader and work our way down from broad questions to super specific. Like I see one question is very specific about somebody's actual cabinet. We'll probably, go towards those types of questions last so we can hit the most common questions first. Before I ask the first question though, Ed, Moose, do you have anything you wanted to add before we jump in?
No, I mean, just to reiterate, on top of all the testing going well and the product working phenomenally, just knowing that we're, somewhat partnering, but utilizing a product from a company that is, based out of the US, you get a real person on the phone when you call, means a lot. And it's really good. I like the way you guys do business. So it's awesome.
And we like how Cerakote does business too. So feelings mutual. It's a really good you know, the philosophy alignment between the organizations was pretty cool, and the branding. EpiX and Cerakote has really similar colors too. When I first saw that, I was like, wow, it's like,
Yeah.
you know, what are the odds that would happen, you know, without having coordinated ahead of time? But here we are. So
I don't have anything else to add. I'm looking forward to answering one of the questions because of the response that you know we had when we were working together, and that one was, how easily does 10X remove Cerakote? And I'm thinking of the Yeti tumbler that we were working on when we were doing the work together, you know, a year ago. When you started working on it, you're like, hey, come here, look at this.
why don't you, since you're there, why don't you answer that question first, Ed? Because that's a great question. Cerakote and powder coat, probably. I would expand the question a bit to just cover some of the other questions related to that.
Yeah, I would prefer if Moose answered that, because
Sure.
it was great to see the reaction when we first did that work together.
Yeah. So it removes Cerakote easy, removes it very similar to like your normal blasting media, aluminum oxide or garnet sand. You definitely got to get your blaster reined in and get the settings set up. And once you get your feed rate and the right nozzle and the right hose size and all that, it blasts like a dream. And the story that Ed was talking about, and this was another selling point to me, was EpiX MP can remove powder coat, fully cured powder coat. And when he was on site, I had a Yeti cup that we powder coated, and it removed it with ease. And if you guys have ever tried blasting powder coat with normal aluminum oxide or garnet sand, it is painstakingly long process. So yeah, I thought that was really cool, but it does remove Cerakote very easy.
All right. So the first question is a little bit long-winded here, but let's dive in. So for someone using aluminum oxide, what differences are you seeing in adhesion and coating durability in the real world if you blast with EpiX MP and change nothing else?
I personally have seen no difference. Hundreds of items have been coated in this facility and then been used in the real world. A lot of those have been blasted with EpiX MP over the last year. Zero real world differences. Through all the tests that I ran, adhesion maintained strong, and all the durability aspects were still killer.
All right. Moose, somebody asked specifically about pencil hardness numbers, and I think they got confused between the H series and Elite series. So they wanted to know if the coatings show any harder when blasted with EpiX MP versus garnet. I know you mentioned something about garnet, but I think maybe we didn't talk about whether it was H series or Elite series. If you could just answer that.
So real quick, I'm going to go back here. Through the colors that I sprayed, the one color that I did see increased scratch and gouge on was burnt bronze. So all of our technical data sheet testing, or the data that you see on there, is all based off of our panels being blasted at normal pressure with 100 grit aluminum oxide, and then sprayed at recommended mill thickness and cured at recommended cure temp. And the only thing that I changed throughout that process with it was then blasting with EpiX MP. And I did see an increase in scratch and gouge. That was about the only color that I saw the increased side. I saw zero colors have a decrease in performance when blasted with EpiX.
I'll add too that when somebody first starts, I don't think they'll lose anything. But as the blaster, the coder, whoever's working on their parts, as they get used to what EpiX can do and they dial it in, they're really lean, and they're moving faster. They're getting a really, clean white metal surface before they coat. I think everyone will see sort of an increase in quality once they get adjusted. And some folks are adjusted in an hour. Some folks are like so used to doing it a certain way that they tend to overfeed for like a week or two, and they start to iterate. Either way, there's a bit of a learning curve, but it's super simple. And as people go on that learning curve, I think the quality goes up regardless of what your coating is on there. Your quality of blast goes up as you get used to the material. It's not it's not bad by any means. It's just so different, and a whole, new way for an abrasive to work, that there's a bit of that learning curve. And as you go through it, I think you're going to get better results. That's been my experience with everyone working on EpiX MP. So,
and like always, I would always recommend when doing any type of major switch like this, do practice parts, blast some practice parts, spray some practice parts, use a mil thickness gauge, make sure you're applying the right amount of coating. And yeah, don't just swap it and start working on customers' parts right away. It does take a little bit of fine tuning. So,
Dwight asked EpiX MP. Yes, Dwight, that's right. We're talking about EpiX MP. And earlier in the chat, I put a link there. We have 2 other products in the EpiX line, but the one that was specifically for Cerakote is EpiX MP. And Moose, while we're on the question of EpiX MP, earlier, I don't actually see the question now, but earlier somebody asked, is there any Cerakote series or colors that EpiX MP is not approved for yet?
No, every series of coating, every line of coating that we offer can be applied over a 10x blast profile.
The EpiX MP blast profile, just to be.
Yes, EpiX MP.
All right, thank you. Ed, we got Tom, whose name came through as Ton for some reason. Sorry about that, Tom. But he asked, is 10x OSHA approved? And he's also asked, OSHA doesn't like silica sand. And I'm going to add on to his question another earlier question we got. Let me see if I can find that. 1 second. Search function is great. Okay, so he asked, is it OSHA approved? Someone else asked, if my guys are blasting with EpiX all day, what, if anything, do we need to change about our PPE? And then he expanded it, said, is it more about peace of mind versus garnet aluminum oxide, or do we need different PPE to meet OSHA's requirement for EpiX? So it's kind of, I feel like those questions are the same, or we're very similar.
So I'll hit the PPE question first. The PPE that you would need to utilize would be the same thing that you would for nuisance dusts. The material would be in line with nuisance dusts. Any dust is something that you don't want to breathe on purpose. The benefit of ours is that it's biosoluble, and if it gets into your lungs, it would be broken down by normal processes, and so it's not persistent. So about the OSHA approval, I'm not aware of OSHA approving or disapproving of abrasives or things. The thing about silica is that it has a high requirement for the PPE and the testing that has to be done in order to ensure that a person is not being exposed to crystalline silica. Our material has no crystalline silica in it, or said according to the exact tests, it is a non-detect at 0.01%, and that that non-detect is if you look at silica sand, it's got a high percentage of crystalline silica in it. Crystalline silica is what is the bad actor that gets into your lungs and then causes silicosis. So Tom, I don't know if that answers your question. There's not a approval process like there is for California Air Resource Board, where they say this is an approved abrasive, this is an approved abrasive, which ours are. But it's more specific to the type of hazard that a employee would be exposed to, and silica is a specific hazard that would expose somebody due to crystalline silica in that material, and our material is non-detect for crystalline silica.
Thanks, Ed. I think this is for everyone. Dan from San Diego asks, what is the typical reusability on EpiX MP?
There's a lot of variables on my end. I couldn't really give you a straight answer. I mean, what substrate are you primarily blasting? how often are you blasting? What pressure are you often blasting at? We add one 16-ounce deli cup of new media into one of our Empire abrasive cabinets every Friday. We're blasting throughout a week, probably 25 hours throughout that week. So, I mean, it holds up pretty well, but that's for our situation here. I don't know what variables Dan has, but it holds up.
And for comparison's sake, I think when we're doing the development on the webinar, you had said that you're adding 1 cup per week, and that on other cabinets that are in other rooms, when you were using aluminum oxide or garnet, you were adding 2 a week. So it's a small amount, but it's definitely much more reusable. And the other benefit that comes along with that is that you're now maintaining a better consistency throughout the week. The less material you have to add, the more consistent the material is that's in the cabinet that you're using. A point of reference, like in our literature, we show that for EpiX MP, we've got a range listed of 6 to 12 cycles. We have folks like so there's one customer that was using garnet, and this was in a automotive application, more of a heavier rust removal, but they were getting 4 cycles out of their garnet, and they let us know that with the material they were getting 8 cycles. So that's like one end of the spectrum. Not knowing where you are as far as number of cycles you're getting right now with your garnet or aluminum oxide, it's tough to say like you're going to see this much more. But we typically, when folks have gone to the length of making sure that it's efficiently dialed in, so it's not overfed, and that they're running the correct pressures, and that it's not being sucked out in the reclaimer, we typically hear that folks are seeing much better life out of the EpiX material than out of the other abrasives.
Great. We got another question. This is about disposal by itself. Could it go into the garbage? Ed, if you could just talk about, regardless of coating, just the abrasive itself. I think we have a unique advantage there. But then we add in the layer of, depending on what you're blasting off, we do need to be aware of that.
So depending on what's in the material that's being blasted off, that will have its own profile as far as its toxicology and leachate. Ours, we actually post on our website the T-clip so that you can see that it is non-detect for, I mean, over 90% of what is listed on the T-clip. And then there's 2 that are detectable, two materials that are detectable, and they're, many times whatever the regulatory limit is. It is directly answering it, yes, it could be put into the trash. It doesn't have a toxic nature or any type of a special waste nature, as long as there's not local regulations that limit industrial trash or things of that nature that would say that just because it came from an industrial generator that it can't go into the trash. One other thing that's interesting that's not necessarily trash related, but it is health and safety, is for another large oil field customer. We had to do fish toxicity testing, and that was done in Washington. And when that was done, we got our results back, we passed, but the lab went the extra length of calling us to say, hey, none of your fish died. And we said, okay, that's great. We thought that was normal. He said, no, it's pretty normal for some fish to die. You only have to have 50% of them live in order to pass. And you guys had none die. And so we knew going into it from all of the studies that were discussed in the IARC monograph that the material was safe, but it was interesting to have it confirmed in a specific test for aquatic life that it was a safe material. Just put that aside, but it's a nugget of information that really supports how safe the material is.
So we got a question. I can answer this one quickly. How do we get your product up in Canada? It's stocked throughout Canada. Already Canada is our distribution partner. They're our exclusive
Mhm.
distribution partner in Canada, and any of their sales and support staff know thoroughly about EpiX and MP, and this is very new. So most of them have been updated about the Cerakote approval, but if you need us to connect you with a specific sales rep in your region, you can always contact 10X
Yeah.
through our website, call us, however you want to get in touch with us, chat. We will get you connected with the rep closest to you. Obviously, Canada is a big country, but again, it's stocked throughout all of the already Canada locations.
Yeah.
The next questions, we're getting a little more specific and technical here. Ed, we get this question all the time. Can this be used effectively with wheel blast systems? Now, I think that's a two-part question. One, we've heard wheel blast systems where they're air blast nozzles and it's like a robot of sorts. Yes, but I would also suggest that you answer a wheel abrader just in case, even though they didn't say wheel abrader, there's a very different way that those systems work, and the answer to
Yeah.
those are different.
Yeah, so for a wheel abrader type where it's a motor-driven wheel that's slinging the material, thus far we haven't found that the density of the product carries, as far as those are trying to throw them. With an air blast system, the particle velocity is there and the performance is there, but when you're slinging it off of a motorized wheel, and the quantities, those are more focused on just throwing a lot of mass at the particle or at the item to be processed. And we're more focused on velocity. Energy delivered to the surface is mass times velocity squared. We're working on the square of the velocity. So that's a long way of saying that it's not something that we recommend for wheel abrader or those types of delivery devices.
Got another question from, it looks like Robert. Robert's asking what the RA tolerances Cerakote recommends or allows across the surface of the part being blasted.
So we are on average, a 1 mil thick coating. And we are looking for right around that 17.5 to 25 micron blast profile. So we're almost looking for that 1 mil blast profile. And this is where our adhesion wins, is we are always adhering to that substrate with that appropriate blast profile. So it'd be right around that 17.5 to 25 micron is what we're looking for as an RA value.
And then Nicholas asked, how does EpiX MP interact with hard coat anodize? We are trying to leave hard coat as a base layer and don't want to blast it all off.
So normally I would recommend 30 to 40 PSI in your blast cabinet, a little bit greater distance, a little bit greater speed. Depending on how your blaster is tuned with EpiX MP, you might need to go as low as 20 PSI. But remember, with hard coat anodizing, you're just trying to dull the sheen of the ano, not completely remove it. So anywhere from that 20 to 40 PSI range. And I personally have had success etch blasting hard coat anodizing with no problems.
Yeah, don't hit it at 100 PSI though.
Nope, we're just etching.
When you had success, that was after you had gotten to, so you'd loaded everything in, but you were now at a working mix, I would guess,
Yep.
when you got that.
Yep.
Okay. Yeah, I think one of the keys is making sure that you get to that working mix before you would go after the polymer parts or ones
Yep.
where you're trying to just slightly etch the surface. And just in a parallel manner, we have customers that will lightly etch galvanized, and galvanized is softer than the hard coat aluminum, but they'll just lightly etch that zinc galvanization for things like 5G poles and other items out there that need to be powder coated. So you can work with the pressure even beyond the table that was displayed in order to get the results that you're looking for in a trial and error fashion.
Yeah.
So, Thank you, guys. This question was earlier. I kind of blew past it, just saw it again. Sorry, I missed it. Do you have a technical guide for settings on soft metals, harder steels, and composites so our team isn't guessing if we were to switch? And I'm just going to go right back to here. Yes, we thought of that. Cerakote has it on their website. Just type in 10X and you'll find the knowledge article. Or if you're on the 10X website, on the support column, just hit Cerakote and that information is right there.
Jake, if you go back one more, it will be, this is a huge summary of what was there, but I mean, the knowledge base article explains that it provides a superior surface and it provides these pieces of technical information. Beyond just these settings though, both companies are going to provide whatever technical support you need. So if there's a phone call that's needed, don't hesitate to do that either.
Long asked, will there be any discounts for certified applicators? I don't think we've set anything up yet, but Cerakote and 10X really just finished a deeply technical process. So I would say, Moose, just stay tuned, subscribe on social media, get on the email, the text list, whatever, follow it and make sure you don't miss the announcement. But Cerakote and 10X are, working closely together, and, we've got a lot of cool stuff we're planning for next year. So no, not yet, but I say stay tuned. We're working on everything we can. And on discounts, I will mention on the 10X website, if you want a discount, once you know how much you need and when you need it, you can, first of all, you get a 10% discount on your first order if you sign up for text, but you get 10% off on every order if you do a subscription. So you can already get a discount just by subscribing on the 10X website. So there is that out there. So we got another question. Eric asked, swapping from aluminum oxide to 10X, does the aluminum oxide have to be 100% cleaned out, or will a little left hurt anything?
I can field that one. It depends on what you mean by a little. We've done switches in the past where folks have just put the 10X in on top of the aluminum oxide, and we recommend against doing that. The reason is the difference in densities is significant enough that it becomes very hard to optimize for one or the other. The aluminum oxide is driving mass against the part. We're driving for velocity. It makes it difficult to tune your reclaimer. So the recommended is to clear out the aluminum oxide and then put in the EpiX material. By a little bit, if you're talking about like, do I need to sweep it or wipe it down or something like that? No, you don't need to go to that level. If there's a little dust in the corner, if there's a tablespoon left in the bottom, small amounts are not going to matter if it's 95%, 99% of the EpiX material. It's if you were to do a slow changeover where you're just adding in EpiX whenever you need material and you're leaving the aluminum oxide in there, there's going to be a point where the two materials, since they behave differently, make it difficult to dial in your metering valve and also set your air wash, your reclaim. We've had the most success with customers that are making switchovers when they use up their aluminum oxide to the point that they're just about empty. Then they dump what's left and then make a full changeover.
That's great. Now I'm going to switch topics a bit, but it's adjacent to what we were just talking about. And we have really three different questions here. First, the easier one to answer is, as a blaster, would you blend old and new? They're talking about EpiX MP. So say this person switched over. This is Daniel who asked this. So Daniel switched over to EpiX MP. Would you blend old and new material in a similar fashion as aluminum oxide or garnet, or would you do it anything differently?
We've been adding new with old, like you would with aluminum oxide and garnet sand, just to keep that good working mix going. We'd never, and I would personally never really recommend running your media till it's ragged and then fully swapping to brand new media. You're just going to go from highs and lows on blast profile. It'll give you inconsistent durability. So yeah, you can add new in with the old on my end. I don't know about you, Ed. What would you say?
100% agree with that, and want to raise what you said many times. Keeping a consistent working mix keeps your parts and your finish consistent, and that's what your customers are going to want to see. You're going to want to see a consistent output. If you go from running the media where it is completely broken down and then you dump it and start over with fresh, you're now going from a low profile situation up to a high profile situation, and it will change the appearance and change it makes unnecessary changes. Keeping a consistent working mix is key. So however you're doing that currently with your abrasive of adding a little bit when you see that it's time, that's a best practice. Keep doing what you're doing.
So we got two questions that are really similar. I'll read them both, but the first one is, do we have any idea on how 10X is wearing on scat blast power heads with carbide nozzles? And I switched us to this page where you can, on the right-hand side, the background is actually a picture of EpiX MP on like a white countertop or something. And the second question is similar, but they're asking, will the product put more wear on their Empire Blast cabinet compared to aluminum oxide or garnet? And there's a second part to that question I'll ask after, Ed, if you or Moose, you guys want to answer the first part of the question on where specifically with carbide nozzles.
We use carbide nozzles in-house in our Empire Blast cabinets. I have seen little to no difference between the two medias. And then as far as the wear and tear on the Empire Blast cabinet, I've noticed no extra wear and tear. Because of the lighter density, I almost think it's easier on the internals, but I could be wrong, but I have not seen any major wear and tear there. So.
We've got customer data that would say that you're correct, Moose. One customer that's on the industrial side that blasts tons and tons of material in weeks' time switched over from aluminum oxide. Now, this was in a much more coarse gradation of our material, but they switched over from aluminum oxide to the 10X product. And after I think it was a few months, they came back and said that they had noticed that their hose life went from 300 hours on the aluminum oxide to 600 hours with the 10X product. In a smaller cabinet, we were doing work with a customer that was blasting tungsten, and they were using silicon carbide, which is also a very aggressive media. And when they switched from the silicon carbide to the EpiX material, they ended up having their bond strength go way up. They resolved an issue that was occurring that was causing a lot of rework, and were able to get that cleanliness level in a fraction of the time. But after they made the switch, they reached out later and said that they were seeing extended gun life, and were using consumables in the blast process less. Jake, by putting up this picture, the thing that's critical about our material is it is a wide distribution of shapes. There's angular, subangular, rounded, and subrounded. And what we find is that it typically flows better through metering valves, and that's why we were talking about the need to adjust. But that flowability and the mixture of angular and rounded particles, it tends to reduce the amount of wear that you see on normal wear items in our experience.
Thank you, guys. Now, the second part of this question is, do they need to do anything once they change over to 10X other than adjusting their reclaimer? And they are specifically working in an Empire blast cabinet.
I can't think of anything specific. Usually making sure that you have it dialed into a lean, making sure that it's lean. If it's overfed, if we get calls in that somebody says, hey, it's slow and it's dusty, then right away we know, okay, we need to help this person to get it properly metered because it's overfed. So if you're overfed or you can see the abrasive like hitting like a fire hose, that would be that's a first adjustment. Pressure is going to be your second adjustment to make sure that you're getting the surface profile. And then the third adjustment is going to be the reclaimer. And Jake, I don't know if we've got it anywhere, but on our website, there's in the technical information, there's a video that shows what it looks like in a cabinet when it's underfed, properly fed, and overfed. And you can see when it's being blasted how that looks. It's been helpful with customers that I've visited where the operator can immediately go, oh, okay, I see what you've given me as a range of what it should look like, and they can get themselves dialed in quite quickly.
Yeah, it's right at the top of our product support page. I just dropped the link to that. That video is right there, so folks can see that. We got a couple more questions here. So this one's probably a shorter answer. Does it spark on steel surfaces?
No, I have not seen it spark on a steel surface. Have you seen it spark on a steel surface, Ed?
I've not ever noticed the EpiX MP to spark. Usually, in order to do that, if you're sparking, you're doing one of two things. The biggest one is you're actually removing a piece of the metal. And at the profiles that we're looking to get for these, we're not getting into that level of energy removal. When we've done work with oil and gas pipelines and things of that nature, in a very low light condition with a very aggressive abrasive, not the EpiX MP, you can see spark generation. But we've not run into anything with EpiX MP where someone would say, "Hey, that was an issue." And we're used in a variety of oil and gas services where if there was any type of a issue like that, it would have become a major issue years before now. So spark generation or an issue like that is not one that I've seen with the EpiX MP.
So our next question is asking about using EpiX MP in a bulk blaster.
Yeah. Moose, do you guys have folks that are set up with full blast rooms where they've got a blast pot typically? Or is that
not
okay?
Typical? Most stuff done in the production side is done in cabinets.
Okay.
Yeah.
Okay. We work with a wide range of customers, and for instance, the one that I was talking about where they were just looking to profile the surface a little bit before coating it, they were in a full operation with a reclaiming floor and a air wash reclaim system and blast pots. So we work with and have the ability to provide technical support for someone that's just using a small blast pot that they may have gotten from Harbor Freight, all the way up to industrial blast operations that have multi-outlet pots and 1600 CFM compressors. So, but those are more often in some of the other grades. Typically in the EpiX MP grade, you'll see the cabinets that you're talking about. And there are pressure blast cabinets, and those perform similarly to a pressure blast pot, and it works just fine. It's actually quite fast at stripping material in a pressure blast application. So it works just fine. And if you wanted to use it for a larger industrial application where you do need to have a separate blast pot, we can work with you on what those settings are. They're listed in our technical data sheet and in our optimization guide. Sorry, they're not listed in our technical data sheet. They're listed in our optimization guide, and that setting process is printed on the back of every bag that we ship out.
Yeah, and I'll add, we have a lot of customers that use EpiX MP specifically in booths, even outdoor blasting, but also we have some customers that once they see how much faster they can go in a pressure pot, they actually plumb a pressure pot into what used to be a suction cabinet. And then obviously they can adjust their pressure up and down as they need for different surfaces. But that's not exactly the question that was asked, but I just wanted to point it out that we do have a number of customers that end up plumbing a pressure pot into their existing cabinet, and they're happy with that. But the product will work in all different kinds of equipment. Matthew asked, what CFM and PSI are you using with EpiX MP? And so I brought this page up. I think the CFM there's not one answer. It depends on your nozzle size. You know, if you've got a bigger nozzle, you're going to need more CFM to get a certain pressure setting than if you have a smaller nozzle. So we have a chart on our website, on our product support page. We even have a nozzle selection guide that shows you all the different pressures. And like if you have a number 5 nozzle, for example, it shows you how many CFM you need to get a certain pressure. So you can refer to that. You can always also reach out to 10X directly, and we can do the math for you if you have a very specific setup that you're trying to nail a CFM down for a given application. All right, we have one more question, and then I think we need to call it. Dwight has designed his blast hood to operate at 35 to 40 PSI. He wants to know if he can start there and then increase as needed with EpiX MP.
Yeah, absolutely. I mean, if you're blasting a lot of composites, it's kind of a perfect range. When you start getting into the metals, you might be a little light on the blast profile, but also there's some variables there. How close are you to the part? How quick are you moving across the part? And you know, how quick are you moving? So I would say, yeah, it's a good place to start. But if you start getting into the harder metals, definitely be willing to crank that PSI up.
Yeah, well, I appreciate that, Moose. And I just want to say thank you, Moose, Cerakote, everyone at NIC, and Ed. Thank you both for making this a great webinar. And again, feel free to reach out to either company with your specific question, and we'll get it routed around and make sure you get an answer. We are here, and I think I say this for both companies, we are here to unlock your success. And that's what this is all about. Your success is our success. So don't be shy. Definitely reach out if you need help. And thank you all for joining the webinar.
Absolutely. Thank you, guys. Appreciate you, Jake. Appreciate you, Ed. Thank you, everyone, for coming out.
Take care.